This lesson's on the binomial theorem. So let's remind ourselves how that works. So we start with the binomial, and we will look at the binomial x plus a. Now, x plus a to the first power is just x plus a, which we're going to think of as 1x to the first plus 1a to the first. Now, if I have x plus a squared, that of course means x plus a times x plus a, which is x squared plus ax, so there's two ax's, two ax's here, and then plus a squared. So we're going to think of that as x squared plus 2a to the first, x to the first, plus a squared. What about x plus a to the third power, which would be x plus a times x plus a times x plus a, or x plus a to the fourth power? So let's take a look. What I want to do here is I want to jump to Desmos. I'll have it go ahead and list those, and we'll see if we can identify some sort of a pattern. That's going to be our approach, if we can. So here I am at Wolfram Alpha. If I go to x plus a to the third power, what does it give me? And we'll see the result. It's taking a while to compute. And we have all kinds of things, but this is the one I want. I'm going to start it from the right. X cubed plus 3ax squared plus 3a squared x plus a cubed. Just writing it in descending powers of x, again, working from this line and going backwards. And I want to go ahead and do x plus a to the fourth, again, trying to see if I can identify a pattern. So let's continue with Desmos and see what it gives us. And again, starting at the right, x to the fourth plus 4ax cubed plus 6a squared x squared plus 4a cubed x plus a to the fourth. So that should be enough for us to identify a pattern. So what can we say here? What's our idea? Well, I want you to notice that the exponents are always the same as the power that we're given here. So I have x to the first, a to the first. I have a to the first, x to the first adds up to 2, a to the second, x to the second. A to the first, x to the second adds up to 3, a to the second, x to the first adds up to 3, a to the third. Of course, x to the fourth. X to the fourth, a to the first, x to the third adds up to 4, a squared, x squared adds up to 4, a to the third, x to the first adds up to 4, a to the fourth. So we can see that idea, but I also want you to focus on the coefficients. So I have 1 and 1 on my top row. Then here I have 1, 2, 1, right? 1x squared plus 2ax plus 1a squared, 1, 2, 1 here. Next, 1, 3, 3, 1. Again, putting in the 1, putting in the 1 at the end. First coefficient is 1, then 3, then 3, then 1. And then the last one I have here is 1, 4, 6, 4, 1. And this is the key idea to the binomial theorem, because this is Pascal's triangle. If I put the 1 on top, you can see what the next row is going to have to be. Notice 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 1 is 3, 3 plus 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. So if I wanted to create the next number in Pascal's triangle, the next row in Pascal's triangle, it starts with a 1. 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and then there's a 1 on the back end. So my coefficients are 1, 5, 10, 10, 5, 1. Keep that in mind. And I'm going to go ahead and I'm going to do x plus a to the 5th power next. And then we'll see how that works with those coefficients. So without multiplying all this out, x plus a to the 5th power is something x to the 5th, right? Because again, 5th power, our exponents are all going to total 5. The next one will be what, x to the 4th times a to the 1st, or a x to the 4th. I'm going to write x to the 4th a. Plus the next one would be x cubed a squared. Notice we have decreasing powers of x and increasing powers of a. Next we would have x squared a cubed. Then x a to the 4th. And finally, a to the 5th. So there's your decreasing powers of x and increasing powers of a, so that they all add up to 5. And what did we say that next row is going to be? 1, 5, 10, 10, 5, 1 from Pascal's triangle. Now we're going to show a way to get there. So we're going to get 1, 5, 10, 10, 5, 1. 1x to the 5th, 5x to the 4th a. 10x to the 3rd a squared plus 10x squared a to the 3rd plus 5x a to the 4th plus 1 a to the 5th. So let's just quickly check that on Desmos to make sure, excuse me, on Wolfram Alpha, to make sure we've done that correctly. So we will do x plus a to the 5th and see what we get. And see if it agrees with what we had previously. I think it takes a little while. So reading it backwards, x to the 5th, check. 5ax to the 4th, check. 10x cubed a squared, check. 10x squared a cubed, check. 5x a to the 4th, check. Plus 1x to the 5th. Very good. Now, how do we get those numbers from Pascal's triangle? We'll talk about that next. Those are actually combinations. So if I want to do x plus a to the 6th power without using Pascal's triangle, I will show you how that's going to work. X plus a to the 6th power. So again, we're going to have coefficients, decreasing powers of x, increasing powers of a. X to the 6th plus decreasing powers of x, x to the 5th, a to the 1st, because they add up to 6, plus x to the 4th, a to the 2nd, plus decreasing powers of x, x to the 3rd, a to the 3rd, plus x squared, a to the 4th, plus x, a to the 5th, plus a to the 6th. We get all of these numbers from Pascal's triangle, which we certainly can do. We're capable of doing that, getting the next Pascal's triangle line. That would be relatively easy. But I want to show you where we can get these directly, so that if we have something larger, it's something we're able to do. 6 is our exponent on this binomial. So we start with 6, choose 0, written this way. Then 6, choose 1. Then 6, choose 2. Then 6, choose 3. 6, choose 4. 6, choose 5. 6, choose 6. What does that mean? If you have 6 items, and how many ways can you select exactly 0 of them? Well, 1. You don't choose any of them. If you have 6 items, how many different ways can you select exactly 1? Well, I always use pizza as my metaphor. If I have 6 different ingredients offered by the pizza place, how many pizzas have exactly 1 ingredient? Well, the answer would be 6. So 6 choose 1 has got to be 6. If I have 6 ingredients, how many ways can I choose 2 of them? First and second, first and third, first and fourth, first and fifth, first and sixth, second and third, second and fourth, second and fifth, second and sixth, third and fourth, third and fifth, third and sixth. You get the idea. So it continues that way. So we list all of the possible outcomes. How do we do this? what is 6 choose 2, 6 choose 3, 6 choose 4, 6 choose 5, 6 choose 6? How do we find that? Well, there is a formula we can use, which we'll take a look at here. The formula, for example, 6 choose 2, we'll start there. 6 choose 2 is 6 factorial divided by 6 minus 2 factorial, 2 factorial. So factorial on the top, 6 factorial, divided by 6 minus 2 factorial, 2 factorial. That's what 6 choose 2 is. So 6 factorial is 6 factorial, 6 minus 2, 4 factorial, 2 factorial. 6 factorial is 6 times 5 times 4 times 3 times 2 times 1 over 4 factorial, 4 times 3 times 2 times 1, 2 factorial is 2 times 1. So you'll notice we get some things cancel, right? 4, 3, 2, 1 goes away. 6 times 5 is 30. 30 divided by 2 is 15. So I get 6 choose 2 is 15. And let me just show you how I can get that from Pascal's triangle. Remember what we said here? The next row will be our next row in Pascal's triangle. So 1 first, 1 plus 5 is 6. 10 plus 5 is 15. 10 plus 10 is 20. 10 plus 5 is 15. 5 plus 1 is 6, and 1. So what does this correspond to? 1 is 6 choose 0. 6 is 6 choose 1. What we just did was 6 choose 2. 6 choose 2 is 15. 6 ingredients. How many pizzas have exactly 2 ingredients? 15 different pizzas. 6 choose 3 is 20. 6 choose 4 is 15. 6 choose 5 is 6. And 6 choose 6 is 1. So we've already shown this. We've already shown that 6 choose 2 is 15. And I'll just go ahead and show you one other combination sort of thing. What if I had 8 choose 5? That's 8 factorial over 8 minus 5 factorial, 5 factorial, which is 8 factorial over 3 factorial, 5 factorial. 8 factorial, 8, 7, 6, 5, 4, 3, 2, 1. 3 factorial is 3, 2, 1. 5 factorial, 5, 4, 3, 2, 1. So 5, 4, 3, 2, 1, 5, 4, 3, 2, 1 goes away. 3 times 2 is 6. 6 is there, and my answer is 56, is 8 choose 5. So it is certainly helpful to do this on the graphing calculator. Let's look at the graphing calculator and see how do we do 8 choose 5. Now, I certainly could do 8 factorial divided by 3 factorial, 3 factorial. On top, 8 math probability factorial. Whoops, 8 factorial here, divided by 3 factorial, 5 factorial. And we hope that we're going to get 56, 3 math, PRB, 3 factorial, 5 factorial, or times 5 factorial, just for emphasis. 5 math, PRB, probability. So now I have 8 factorial divided by 3 factorial, 5 factorial, and it gives me 56. But there's a faster way to get there. Watch. 8 choose 5. 8 math probability. The combination is number 3. 8 choose 5, written that way on this version of the calculator. 8 choose 5 gives us how much? Gives us 56. So that when we come back to this, if I want to do x plus a to the 6th power, I can get all of those combinations from the graphing calculator. So you'll notice, what do I have first? First thing I have for x plus a to the sixth, I have 6 choose 0 x to the sixth. What is 6 choose 0? 6 math choose 0. 6 choose 0 is 1. Again, that's the first number in our Pascal's triangle. So we're going to say x plus a to the sixth. 6 choose 0 is 1, x to the sixth, plus 6 choose 1. You go ahead and show you that again on the graphing calculator. We know what it'll be from Pascal's triangle. 6 math choose, which is number 3. 6 choose 1 gives us 6, of course. So then our next one would be 6x to the fifth a, which I would like to write as 6a x to the fifth. So continuing with that idea, 6 choose 2 is 15. A squared x to the fourth, a squared x to the fourth, plus 6 choose 3 is 20. A cubed x cubed, plus 6 choose 4 is 15. A to the fourth x squared, plus 6 choose 5 is 6. A to the fifth x, plus 6 choose 6 is 1. A to the sixth. So that's how I can get that, using the calculator to help me do some of that. Now, we may not always just be using x plus a, right? So what if I have x minus 3 to the 7th power? So we know that we're going to have decreasing powers of x and increasing powers of -3. So this will be something x to the 7th plus something x to the 6th, -3 to the 1st, plus something x to the 5th, -3 to the 2nd. Plus something x to the 4th, decreasing powers of x, -3 to the 3rd. Notice the powers always add up to 7, plus something x to the 3rd, -3 to the 4th, plus something x to the 2nd, -3 to the 5th, plus something x to the 1st, -3 to the 6th, plus something x to the 0, -3 to the 7. Now, what are all those numbers? The first number is 7 choose 0, which I know is 1. That's the first number in Pascal's triangle. The second number is 7 choose 1, or 7 choose 6. They're the same. So if you want to make it 7 choose 6, you can. I like to think of it 7 choose 1 first. 7 choose 1 is 7, which is the same as 7 choose 6. So we have 1 on the back end. We have 7 here. Next up, I need 7 choose 5 or 7 choose 2. 5 and 2 are my exponents. What is 7 choose 5 or 7 choose 2? They should be the same. Let's jump to the graphing calculator and see what that is. 7 math probability. 7 choose 5. Whoops, wrong one. 7 math probability number 3. 7 choose 5 or 7 choose 2 gives me 21. So I have 21 here, and then I also have 21 here. Then I need 7 choose 4, which is the same as 7 choose 3, so those two numbers will be the same. So these two, right? I have a 4 and a 3, 7 choose 4, or 7 choose 3 for these two slots. So we'll go back to the graphing calculator and see what is 7 choose 4. 7 probability choose 4. Not sure why I use parentheses, but it doesn't hurt. 7 choose 4 is 35. But we are not finished, right? So we've put in all of those multipliers, but now we have to simplify this. So what do we get next? What's next? Well, what do I have? I have 1x to the 7th, okay. Plus -3 to the 1st times 7 is -21 x to the 6th. Plus -3 squared is 9. 9 times 21 gives me 189 x to the 5th. Plus, now I have 35 times -3 cubed. Times -3 to the 3rd power is what? Is -945. And we were at what? We were x to the 4th. Plus -3 to the 4th times 35. That's our next one, right? So there's our -945. Now we have -3 to the 4th times 35. So I'll save myself some time. 35 times -3 to the 4th gives me 2835. That's x to the 3rd. So we can see that, right? 2835 x to the 3rd. Now I have plus 21 times -3 to the 5th x squared. Okay, 21 times -3 to the 5th gives me -5103 x squared. So we can see that again. 21 times -3 to the 5th x squared, -5103 x squared. -3 to the 6th times 7. Seven times -3 to the 6th gives us 5103 again. And then I get plus -3 to the 7th. That's the last thing I need, right? So I have -3 to the 6th times 7, 5103. Then -3 to the 7th times 1. That's how this ends. -3 to the 7th. Gives me -2187. So here's where we are, right? We've done all of this. Can we write that in a more pleasing fashion? Make all the plus negatives minus. So x to the 7th minus 21 x to the 6th plus 189 x to the 5th minus 945 x to the 4th minus plus, excuse me, 2835 x to the 3rd minus 5103 x squared plus 5103x minus 2187. Now that's a long, nasty problem. Now remember, that was x minus 3 to the 7th power. Let's check that on Wolfram alpha. X minus 3 to the 7th power. We're going to get x minus 3 to the 7th power, and we'll see what Wolfram alpha tells us. We hope it looks the same as what I have. And there you go. X to the 7th minus 21x to the 6th plus 189x to the 5th minus 945x to the 4th plus 2835x cubed minus 5103x squared plus 5103x minus 2187. So that looks good. Now, let's take a look at one more sort of problem. If I have 2x plus 3 to the 5th power, and I want to know what is the coefficient of the x to the 4th term. Well, again, we know we have decreasing powers of x and increasing powers of 3. So it's something 2x to the 5th plus something 2x to the 4th, 3 to the 1st. That's what we're going to need, right? Plus something 2x to the 3rd, 3 squared, plus something 2x to the 2nd, 3 to the 4th. Remember, the exponents have to add up to 5, plus something 5, excuse me. There we go. 2x to the 2nd, 3 to the 3rd, plus something 2x to the 1st, 3 to the 4th, plus something 3 to the 5th. That's how this is going to look. Now, I want the x to the 4th term. Remember, this first one is 5 choose 0, then 5 choose 1, then 5 choose 2, 5 choose 3, 5 choose 4, 5 choose 5. So I asked for the coefficient of the x to the 4th term, which would be here. So if we focus on that, what do we have? We have 5 choose 1, 2x to the 4th, 3 to the 1st. 5 choose 1 is 5. You can get that from the calculator. 2 to the 4th times x to the 4th times 3, which is 5 times 16 times 3. What is that? 5 times 16 times 3 gives me a total of 240. So we get 240 x to the 4th. Let's take a quick look at this on Wolfram alpha and see if it checks. So 2x plus 3 to the 5th power. And we are looking for the x to the 4th term, and we hope it's 240. And we're going to wait for it to do it, and sure enough, you can see 240 x to the 4th. Let's just do one more in this vein, and we'll make the numbers ridiculous, like 3x minus 2y to the 11th. And let's say we want to know the, remember the exponents have to add up to 11. So how about the x to the 8th, y to the 3rd term? We want to find that coefficient, okay? So it's either 11 choose 8 or 11 choose 3. That's what we're starting with, fine. Let's go with 11 choose 8. And then I need 3x to the 8th, and I need negative 2y to the 3rd. So all of this will be, again, 11 choose 8 times 3 to the 8th, x to the 8th, negative 2 to the 3rd, y to the 3rd. And let's see what these numbers are. 11 choose 8, 11 math, PRB, 11 choose 8 gives me 165. So what do I need after 11 choose 8? I need 3 to the 8th. 3 to the 8th power will be a very large number. 65, 61. Then I have x to the 8th. And what do I need after x to the 8th? I need negative 2 to the 3rd. Maybe you can do that in your head. It's negative 8, but I'll show you anyway. Negative 2 to the 3rd power, of course, is negative 8. And then I have y to the 3rd at the end. So I've got to multiply 165 times 65, 61 times negative 8, and all of that is multiplying x to the 8th, y to the 3rd. That will give me the coefficient. So let's jump to the calculator and do that multiplication. And we get 165 times 65, 61 times negative 8. And the result is this very lovely number, negative 8,660,520. So this is what we believe the coefficient is of the x to the 8th, y to the 3rd term. I don't know if Wolfram Alpha will be able to do this, but let's try it. And let's see, 3x minus 2y to the 11th power. 3x minus 2y to the 11th power. We're interested in the x to the 8th, y to the 3rd term. We hope it's negative 8,660,520. I'm not surprised this is going to take a little while to do. And they're giving us all kinds of things here. Oh, it looks like it's there. Okay, that was actually pretty fast. X to the 8th, y to the 3rd term. Can you see it? There it is. Negative 8,660,520, which is what I thought it would be. Makes me feel pretty good about that.